Good afternoon, all of you. So we'll start with today's quote. It says, sometimes the wrong choices still lead us to the right places. Okay, many times we hesitate to do something, thinking that whether it is a right choice or wrong choice. But with that doubt, we should not stop doing things. Okay, if you don't do anything, nothing will happen. Okay, it will not lead us to any place. So sometimes wrong choice also may lead to the right place. So mainly you have to remember that never give up. Okay, you have to do. The action must be there. Then only something will happen. And what happens anyway is not in your hands. Okay. And today is the birthday of the great mathematician and scientist, physicist, and Laplace, because we are all familiar with Laplace's equation, right? So Laplace was a French mathematician, physicist, statistician, astronomer, and known for his mathematical analysis of the stability of the solar system. And he alleviated Isaac Newton's concerns about perturbations between planets. He took an exact approach to science. He developed an explanation of surface tension of a liquid in terms of intermolecular attractions, investigated capillary action, and the speed of sound. So many contributions he has done. And he assisted Lavoisier investigating specific heat and heats of combustion, initiating the science of thermochemistry. He believed the solar system formed from a collapsing nebula. He contributed to the mathematics of probability and calculus, in which a differential equation is known by his name, Laplace's equation, and was involved in establishing the metric system. So much of contribution in so many areas of engineering he has. And he says, all the effects of nature are only the mathematical consequences of a small number of immutable laws. So you can see that the complete nature, whatever is happening, follows laws. Okay, so that's very important, and understanding of the nature through numbers, right? So all the CMTE and all came to life only because of such thoughts and ideas. Okay, today we will continue the axial flow turbines. Last class we had a brief discussion on axial flow turbines. So we will continue that. So this is the general layout of jet aircraft if you see. So compressor, you can see there are so many stages of compressor and combustor, and then we have turbine. There are only 3 stages of turbine here and so many stages of compressor here. So as I was told, it is because the pressure gradient is adverse pressure gradient in the compressor and favorable pressure gradient in the turbine, because the pressure will be decreasing in the turbine. There will be expansion and a decrease of pressure. Because of it is favorable. I can have a large pressure ratio per stage, and so the total number of stages that are required by the turbine are very much less compared to the total number of stages that are needed by the compressor. Okay, so this is the way we will have. And so after the combustor, we will have the turbine here. This is a triple stage turbine with single shaft system. So you can see here, axial turbine can be single stage or multi-stage. And this is a single stage turbine here. You have a set of nozzles and then rotor blades. Okay. And here we have a 3-stage turbine. So this is nozzles, rotor, and actually stator will come from the casing. So here in the gap I will get a stator and rotor, and again there will be stator and rotor, like the 3 stages. And this is the TS diagram. So if you just will try to draw it. So in the last class again, we will just recollect what we have done. We have compared compressor and turbine. So in this, we have seen that what are the differences. This is adverse pressure gradient, and here this is favorable pressure gradient. So pressure increase here and pressure decrease here. And because of that, the pressure ratio per stage is very less, and the pressure ratio per stage can be high. So therefore, number of stages needed are more for a given pressure ratio. Here, number of stages needed are less. So here, work is negative. Here, work is positive. Okay, so that's what we have seen. And so a turbine, and another thing we can write is here there will be rotor plus stator or stage. Here stage contains stator plus rotor. First stator and then rotor. So turbine will have stator first and rotor next. So we get the work from the rotor. So work is positive here. That is work transfer or energy transfer takes place here. Okay. In stator, no energy transfer. Only energy transformation occurs. So here energy transfer plus transformation occurs. So because work is positive, there will be increase in the decrease in the kinetic energy. Okay. So work is positive means so work is taken out. So because of that, enthalpy decrease and absolute velocity decrease. Okay, anyhow, because it is expansion, pressure decrease. And because pressure is decreasing, relative velocity increases. So here in stator, here also because favorable pressure gradient, pressure decrease, and because of that, relative velocity increase. And because there is no energy transfer here, so work is 0, Q is 0, and because of that, H naught is equal to constant. So T naught is equal to constant. And P naught equal to constant if no losses, and P naught decrease if there are losses. Okay, here because W is positive and Q is 0, W positive, and because of that H naught decrease and T naught decrease, and P naught decrease. And coming to as already written, C decrease, P decrease, and because P is decreasing, rho decrease, temperature decrease, okay. And only relative velocity increases because pressure is decreasing. And so because relative velocity increasing means area decreasing or width of the passes decrease. In the cascade, if you draw, width of the passes must decrease. So if you just look at the velocity triangles and cascade. So first I will have nozzle. And from the nozzle, I will have large. So if this is 1, okay, here nozzle and rotor. So here this will be 1, this will be 2, and this will be 3. Let's try it again. Okay, first I will draw rotor. Like this, and it will be like this. And because it is coming from the nozzle, there will be large velocity C2, and it should be C is equal to V plus U. So I have to add U. Like this. So this is V2. This is U. Because this is axial flow turbine, okay, and similar to axial flow compressor, U1 is equal to U2 is equal to U, CA1 is equal to CA2 is equal to C. That is the base and height of the triangles are same. So this is one important thing. Okay, so V2 comes here like this, and my inlet should be tangential. It should enter nicely here. So inlet angle should be like that. So if I take the angles, and again with axial direction, C2 angle is alpha 2, and V2 angle is beta 2. And so here, because it is, and if you see here, this is the area of the width at the entry to the velocity, and here it comes like this. So relative velocity should increase. And so if I add U here, I will get C3 here, like this. And so this is the height of the triangle, that is CA, and the viral components this is VW2, that is CW2, this is U, this is CW3, this is VW3, and angles C3 is alpha 3, this is V3 angle beta 3, and this C3 angle is alpha 3, like this. Okay, so this is the way we have to draw, and this is first stage. And here also again, if I have one more stage, I should have stator 2 or nozzle 2. Okay, so it enters with C3 here. It enters with C3 and again it leaves like this. Okay, so if here I have a nozzle, okay, through which it comes with C2. Okay, if it comes with C2 like this, and if this C2 and this C2 same, it will be repeating stage. That is actually if C1 equal to C3, I will have repeating stage. So whatever is entering the first nozzle and whatever is entering the second nozzle, if they are same, right? So C1 equal to C3, then it is called as repeating stage. Okay, so if my diagram is not, I think if you understand, it's okay. If diagram is not clear, I will show the slide. Yeah, this is so you can see this is the first nozzle. It is coming with C1 and alpha 1, and it is increasing, the velocity is increasing, C2 with alpha 2 it is coming, and this is the rotor. It enters the rotor and it comes out like this. Okay, so this is C2 comes from U plus V2, and you see that when it is coming out, this V is increasing because pressure is decreasing, relative velocity will be increasing, and C2 will be decreasing because I'm taking out work, so C decreases. Is everything clear from this figure? Yeah. So this is the way. So if this C1 and C3 are same, means it enters the next stator in the same way as it is entering the first rotor. Okay, so it will be repeating stage. I can have same stator and rotor then. Okay, that's why it's called repeating stage. Okay, this is the way the velocity triangles will be. And so here, because both bases are same and height are same, again, I can overlap both of the triangles. Okay, so I draw the base, okay, and C2 is like this and C3 is like this. This is CA. Okay, and this is U. This is C2. This is V2. This is VW2. This is CW2. Okay, and I draw the outer triangle. So here V2 has to increase, so it comes like this, and it comes like this. So height of the triangle must be same. Okay, angles also, and angle of V2 is beta 2, and angle of C2 is alpha 2. And the height of the triangle, and this larger one is V3 and smaller one is C3. So you can see that V is increasing and C is decreasing. V3 greater than V2 and C3 is less than C2. And again the angles, this will be alpha 3 C3 angle, and this will be beta 3. And again this is CA. The height of the triangle is same. Base of the triangle, this is the base of the triangle, which is same as U. Okay, so you must be you must feel easy and comfortable by drawing the triangles. Okay, so that is important. And now I will write again similar to the relations that we have drawn. We have written Similar to that we have written. So here U is equal to, from the inlet triangle, how can I relate CW and VW? U is equal to, CWT is the large one, VWT is the small one. So CW2 minus VW2 from the inlet triangle. And from the exit triangle, okay, I didn't write it. So this is CW3 and this is VW3. So I can write it as VW3 minus CW3. Am I clear about it? Any doubt you ask me, right? So from this, I can write CW2 plus CW3 is equal to VW2 plus VW3. And if I write in terms of CA and angles, so I can write this as CA into CW2 by CA is tan alpha 2. So tan alpha 2 minus tan beta 2 is equal to CA into tan beta 3 minus tan alpha 3, right? And from these two, I can write tan alpha 2 plus tan alpha 3 is equal to tan beta 2 plus tan beta 3. This, if I divide by CA, U by CA, that is 1 by 5, U by CA is equal to tan alpha 2 minus tan beta 2 or tan beta 3 minus tan alpha 3. Like this I can write. Now coming to the work, W is equal to U into change in CW. Okay, so I have to write CW2 minus CW3 I have to write. But if you see here, CW2 is in the right side direction and CW3 is in the left side direction. Can you see it? The component of C3 is in the left direction and the component of C2 is in the right direction. Can you identify it?
Yes, sir.
So because of that, if I want to find out the change, okay, CW2 minus CW3, so it will become plus CW3. Okay, suppose it is going with 100 kilometers this side and it has changed in the reverse way to 50 kilometers. What is the change in velocity? 150, right? Am I clear about it?
Yes, sir.
Yeah. So CW2 plus CW3. And from this relation, because I want to write in terms of blade angles, I can write U into VW2 plus VW3 or UCA into tan beta 2 plus tan beta 3. Like this I can write that. Okay. So I'll write in the next page. W is equal to UCA into tan beta 2 plus tan beta 3. So here also I define what is called as work coefficient, but maybe to confuse or something, right? There is a small uh, problem is there. So the work coefficient are also called as blade loading coefficient, which is psi. Okay, so the psi is defined as W by, in compressors we have written as W by U square, right? But here it is taken to be half U square. So this is the only small change is there in the definition. Okay. Anyhow, it is non-dimensional work only. Okay, but it is given by 2. That is 2W by U square. So if I substitute W here, uh, so I will get 2CA by U into tan beta 2 plus tan beta. And CA by U is phi. So psi is equal to 2 phi into tan beta 2 plus tan beta 3. Okay. And this is W. Okay. These things we have to remember. And also we have 1 by phi is equal to tan alpha 2 minus tan beta 2 or tan beta 3 minus tan alpha 3. So this also we got another relation, and phi is equal to CA by U. This is flow coefficient. Okay. So once these things we write, there is only one more thing we are left out is reaction, right? Definition is same. Reaction is equal to delta H across rotor by delta H across stays. Means in the rotor I have H2 minus H3 because it is entering at 2 and leaving at 3, and stays means H1 minus H3. And in the previous one, if I take, so W is also equal to H naught stays. Okay, because delta Q is equal to dH naught plus delta W. Okay, this is the way we got delta H naught of stays. So delta Q is 0. So delta W is dH naught S or H naught. Okay, sorry, the H naught S or CP d T naught S. That is equal to Cp into T naught 1 minus T naught 3. Okay. And so here if you come to H1 minus H3, if C1 is equal to C3 for repeating stages, 2u CA into tan beta 2 plus tan beta 3.
जी
Yes?
Sir, your screen is not visible.
Not visible?
Yes, sir.
so you were
So you are
disconnected.
disconnected.
Disconnected for.
Disconnected. Okay.
Yes.
Yes, I will check again.
Sir, can you please share the screen again, sir? It is not visible.
Now, can you see me again?
Yes, sir, we can see you.
Okay. Again, I will share my screen. Suddenly network is lost here. Hello, can you see my screen?
Yes, sir, it's visible.
Yes, sir.
Here only there is some network connection. It is coming network problem and again going and coming. So I hope hereafter it may be okay. So you can see my screen, right? So here, did you miss anything? Actually, the so again.
Sir, you can turn off your video, sir. You can get little better connection.
Okay. I will see. Okay, is it okay again?
Yes, sir. Okay, sir. We can listen.
Okay. I'll try to continue. So can you see the slide that whatever I written?
Yes, sir.
Okay. So now coming to the reaction I am defining. Okay. So again, I will do this reaction thing. So if connection is lost, you tell me, and if connection is lost, I cannot listen to you also. Okay, I think it's okay. So reaction is delta H across rotor by delta H across stage. So across rotor, it is H2 minus H3. Across stage, it is H1 minus H3. So if C1 equal to C3 and
Sir.